We are on the review packet for 3.1 through 3.5. So starting on 3.1. Number 1, suppose you're hiking up a large mountain. Your initial elevation, initial means your starting point, is 300 above sea level, and then for every hour you hike, your elevation increases by 350 feet. So we are starting at 300, not at 0. Starting at 300, going up by 350. Write an equation relating your elevation to the number of hours you have hiked. So again, we are starting at 300, and we are adding 350 for every hour. So if it was 2 hours, you would do 350 times 2 and add that to your initial or your starting height of 300. Now, an equation has to have an equal sign, which means something needs to be on the other side. So if you left it just like this, it's an expression. Equal sign makes it an equation. And so what is this equal to? That's the elevation. So let's put an E for elevation. And if you were going to define your variable, H equals hours. So complete the table at the right. When you have hiked 0 hours, you haven't done anything. This is your starting point. That is 300. And now you're going up by 350. So you add 350 to this. And that's 650. You add 350 to that. It's 1,000. So every time we're adding 350. So then it's 1,350, 1,700, and 2,050. Now, if you were going all the way up to a really big number, you don't have to count by 350. You could just plug that number into the equation. So if you plugged 5 into the equation, you would multiply by 350, add 300, and you'll get this. Now, what's your elevation for hiking after 4 hours? Find it right here, 1,700. If you were to graph the relationship between all of this, would it be discrete or continuous? So we need to make sure we understand these words. Continuous is a little bit easier to understand because it's a word we use more often just in everyday life. So continuous means it's never going to stop. And discrete means there's breaks in it. So if we made a graph, would we graph this with points like this, or would we graph this with a straight line? So the difference between these two is this one means you're only going to get values on certain numbers. And usually we're talking about whole numbers at that point. Where a continuous graph means that even between the whole numbers, there are values that are important to the situation. So you're hiking, you don't magically go from 300 to 650, right? Something's happening in between. There is a point that you are 400 feet above sea level after a certain number of minutes. So there's values between these points, and there's something we would like to measure and show. So we want to include all of these rational numbers, which we haven't talked about, real numbers, okay, not just integers. And so this would be a continuous graph. All right, number 2. The judge decided to fine speeders $50 plus $10 for every mile per hour they were going over the limit. So write an equation. So 50 plus $10 for every mile per hour. I'm going to use an M. Equals, and I'm going to call this my fine, so I'm going to use a F, where M equals miles per hour over the limit. So $50 plus 10 times however many miles over the limit, miles per hour over the limit, equals your fine. Complete the table below. So if you are 5 miles over the limit, each one of those is $10. So 5 times 10 is 50. Plus you pay the initial 50. So you're plugging in your number. 5 times 10 is 50. Plus 50, that's 100. Plug in 10. 10 times 10 is 100. So you're paying $100 for your miles per hour over the speed limit. Plus you're paying that original $50. So that's 150. Notice that when this went up by 5, this went up by 50. This is linear. Okay, it's going to continue to do that. So we can follow this up, and it should be 200 and 250 because this is counting by 5s consistently. So if you plugged in 15, 10 times 15 is 150, plus 50 is 200. And you can see then this is going to be 250, 300, and 350. Letter C, we're going to plot this. So go to your 10. This should be at 150. Go to your 20. This should be at 250. And then 30 will be at 350. And 50 is also a point on here. That would be your 0, although you shouldn't get a fine, right? You shouldn't get a fine at 50. You're going the speed limit. At 0, I should say. If it's 0 miles per hour over the limit, you shouldn't get a fine. But theoretically, in this algebraic case, it would be 50 because you haven't added any 10 to it. So your starting point is 50. Now, there are miles per hour between 10 and 20 and 30, right? You don't just get a ticket if you go 10 or 20 or 30. There's something between it. So this is a continuous graph. We can connect it. All right, how much over the speed limit was Jared driving if he received a fine of 250? So here's your fine of 250. So it's 20 miles per hour. Now they want you to label this on the graph. So where is the point where he was going 20 miles per hour and it was $250? It's right here. And that's the point. X comes first. That's the point 20, comma, 250. All right, on to 3-2. Starting on number 2. Avery's saving for a used car costs $12,000. He already has $3,350 and he saves $325 per week. So he has this and he's adding this. Let's start there. $3,350 is the starting point and he's adding $325 for every week. When is this going to equal $12,000? Now the directions here say define the variable. So W equals weeks. That's what defining the variable means. And then represent the relationship with an equation. That's what we did. You don't have to solve it for this one. The directions say just write the equation. So if we wanted to solve it, we would minus this from both sides, get W by itself by dividing, and then that would tell you how many weeks it's going to be when he gets to $12,000. But we don't have to do that right now. Okay, in 3 and 4, we're going to solve the equation by making a table and then circling the row that contains the solution. So we're just making this part of the table for 4x minus 3, the expression. And we want to know what x value, which are these numbers we're plugging in, what x value creates the 9. So we're going to find the 9 on this chart. So if I plugged in a 1 to the expression 4x minus 3, 4 times 1 is 4, minus 3, that's 1. I'm plugging in a 2 here. The x is what's getting plugged in. 4 times 2 is 8, minus 3, that's 5. So 4 times 3 minus 3, that's 12 minus 3, that's 9. And that's what we're looking for. So this is my answer. But if we finish the table out, 4 times 4 is 16, minus 3 is 13, and 4 times 5 is 20, minus 3 is 17. So number 4, we're looking at the expression 3x minus 5 and plugging in different x values. When does it equal negative 4? So plugging in 1, it's negative 3 times 1, that's negative 3, plus 5, that's 2. Negative 3 times 2, that's negative 6, plus 5, that's negative 1. Negative 3 times 3, that's negative 9, plus 5. That's negative 4, and that's what we were looking for. So this is the solution. So 3 is the solution. When is the value of the expression negative 4? It's when x equals 3. Negative 3 times 4 is negative 12, plus 5 is negative 7, and negative 3 times 5 is negative 15, plus 5 is negative 10. Okay, 5 and 6. We're going to solve the equation by making a graph and then drawing lines from the y-axis to the graph and then show it. So we're doing the same thing as we did here, except on a graph. And then we're going to show on the graph, where does this expression equal negative 2? Where does this expression equal 5? So in order to do this, you probably do want to make a quick table. And you're doing the same thing we just did up here. You're going to plug numbers in. So I'm going to start with 0. Just looking at the expression, plug in 0. Negative 2 times 0 is 0, plus 4 is 4. So my first point is 0, 4. Plug in 1. So here's 1 on the x, and we're going to plot whatever we get for y. So put 1 in. Negative 2 times 1 is negative 2, plus 4 is 2. So I have 1, 2. So we got to get to negative 2, down here somewhere. The value of this expression, the answer I get after I plug something in for x is negative 2. So 2, negative 2 times 2, that's negative 4, plus 4, that's 0. So 2, 0 is right here. These are ordered pairs like this, 2, 0. Okay, it looks like we're getting close. If I follow this pattern, I'm going down 2 over 1, down 2 over 1. I'm going to end up here. Number x equals 3 is going to get me the value of -2. So the answer should be x equals 3. But let's see. Plug in 3. -2 times 3 is -6. Plus 4 is -2. So it's 3, -2. And I've done enough to find the solution that I need. So the answer here is x equals 3. When does the value of this expression equal -2? It's when x equals 3. And then where do you show that on the graph? So you go to where x is 3, and you're going to draw a dotted line to this, and then show that it created the -2. So from the -2 to the graph, up to the x value that created it, which was x equals 3. So same thing here, quick xy chart to get this on the graph. Plug it in, let's start with 0. This is what you're looking at, the expression. So plug in 0, 3 times 0 is 0, plus 2 is 2. So 0, 2 has to be on this graph. A 1, 3 times 1, that's 3, plus 2 is 5, so 1, 5. So I wouldn't go on to 2 because clearly this graph is going up, so it's going to end up off of my graph. Now, you might have already noticed we're trying to find 5, so we've already got it right there. So let's do one more point so we can continue this graph, but we've already found the value. The value of this expression equals 5 when x equals 1. You can see it in the table, and you can see it on the graph right there. So let's just do one more point here, -1. 3 times -1 is -3, plus the 2, that's -1. So -1, -1 is that point. So we can draw the line now. And the point on the graph where we see this is right here. Let's do a better job of just making sure we see those lines that we're creating to show the solution on the graph. So it says, make the graph and draw lines from the y-axis to the graph and then the x-axis to indicate the solution. That's what we're doing. Okay, the value of this expression is 5, so going from y equals 5 to the line, and then down to the x value, x equals 1. Okay, on to 3, 3. So in 2 and 3, we're going to say what was done to each side of the equation to arrive at this. So we don't have to do the work's been done, but take a look. This was the original. The -41 is gone, so how did they eliminate it? The 99 went to 140. So this is gone. Think about what you would do to get rid of this. How do I get this to 0? But also notice the 99 went to a 140. So how did I get from here to here? And how did this go away? Well, they added 41. That clears this out to 0. When you add 41 to 99, you get this. So they added 41. And number 3, how'd they get from here to here? So A is now by itself. You take a look, this right here, this says multiply. 0.02 times A equals 1.6. So we've talked about we're going to divide by 0.02 on both sides. You should try it out, make sure that that's what they did. So we're going to do 1.6 divided by 0.02, and sure enough, that's the 80. That's where they got the 80 from. So what did they do? They divided by 0.02. Now there's always a multiplication option here. We've talked about that dividing by a fraction is the same as by multiplying by the reciprocal, but in this case we're not dealing with fractions. So more than likely you're just going to divide by 0.02, and we're not going to get into anything further than that. All right, number 4, fill in the blanks. Say what happens first. So if I was trying to solve this equation, the first thing I'm going to do is get rid of this 61. So I'm going to subtract 61. It's a positive 61, so I subtract 61. And you'll notice on the answer key, they said add -61. Subtracting 61 and adding -61 are the same thing. So I don't like to make it complicated. Why would I add a negative if I can just subtract 61? So I'm going to keep it simple. And then I'm going to divide by -7. Divide by -7. And you'll notice that in the answer key, they said multiply by -1/7. That's the same thing. Multiplying by 1/7 is the same as dividing by 7, but I'm going to keep it simple. So both answers are acceptable, but let's keep it simple. All right, tell what was done for each step. So for the first one, this is still here. What did they do? They got rid of 72. How do we get rid of 72? We minus 72. It's positive. Ignore this minus. That goes with the 18. It stays with it. How do I get this to 0? If you add 72 to 72, you get a bigger number. We need to minus 72. And you'll notice that on this side, the number got smaller. 864 became 792. That means they subtracted 72. And then here, we know that we're always going to divide. So they divided by negative 18. All right, we're going to solve and check. Now, we didn't have to check all of these, but we'll run a couple checks just to make sure we know what we're doing. So real quick here, x is on the left side. We're going to minus 12. We're trying to isolate that x. So 7x equals 14 divided by 7. And x equals 2. If you were going to run this check, you plug 2 back in. So 7 times 2 plus 12 equals 26. I highly recommend you do this on the quiz. Then you know if you got it right. So 7 times 2 is 14, plus the 12 is 26. I end up with 26 on both sides. Therefore, I know my answer is correct. There's no guesswork at that point. You know it is right. All right, x is on the left side here on number 2, and I want to get rid of this negative 3. The only way you get rid of a negative 3 is to add 3. That gets it to 0. So we got to add 3. So 4x equals 16. Divide by 4. X equals 4. I'll do one more check for you, because you didn't have to do them, but I want to make sure that you've got this skill. So it's negative 3 plus 4 times your answer of 4. So that goes in for x. 4 goes in for x. We need to make sure this left side comes out to 13. If our answer is right, it will. So it's negative 3 plus 16. That is 13. So I get 13 on both sides. Check works. I know my answer is right. Okay, number 3. Add 8. So I get 35 equals 2w. I'm going to divide by 2. Now that doesn't divide perfectly, but it is a nice decimal. 35 divided by 2, 17.5. Number 4, I see a fraction. Okay, but I'll deal with that last because it's attached to the variable. So first thing I'm going to do is try and isolate this variable. So I'm going to minus 13. So I've got 4/7 t still left over, and then I get negative 16 on this side. Now, you got two options. Let me show you both. So I've just rewritten the equation. Two different ways. You can divide by 4/7 if you want, because this is multiplication. 4/7 times t. How do we undo multiplication? We divide. That will work. You can also multiply by the reciprocal. We've talked about that. To get rid of a fractional coefficient, you can multiply by the reciprocal, which would be 7/4. So let me show you one, how to do this with a calculator, and two, that you get the same answer. So anything divided by itself is 1, so this eliminates, and negative 16 divided by your fraction button, alpha x, 4/7, and you get negative 28. So we get t equals negative 28. Now let's say I did it over here. Multiplying by the reciprocal creates a coefficient of 1, because you get 28 on top, 28 on the bottom. 28 over 28 is 1. So this goes away, and that's why we did it. But then what happens over here? Negative 16 times the fraction, 7/4. And there you go. You get the same exact answer. So both of those ways are acceptable. Whichever way makes more sense and you're more comfortable with, go with that. But the answer is negative 28. Okay, number 5. We've got a little bit of simplifying here to do. So we've got this in parentheses, but we're adding everything, so the order actually doesn't matter. So we can combine our like terms over here. N is just going to be by itself, so it's n. And then right here, the 2 and the 9 go together. That's negative 7 equals negative 7. Instead of writing plus negative 7, you can write minus 7. But how do I get this to 0? I have to add 7. Add 7. Now I'm left with just n. Negative 7 plus 7 cancels. But we have to fill this space. We don't just stop working. It's 0. And that's the answer. And if you ran a check, you'd have to plug in a 0 to make this work. So 0 is a number. Don't be scared of 0. Students a lot of times think they did something wrong if they get 0. 0 is a number, just like every other one. All right, over here now we got decimals. We're still going to handle this the same way. The variable's on the left side. Let's eliminate everything that's over here. So it's 1.27p, and we'll let the calculator handle the decimals. And now this is a coefficient being multiplied times p. How do I undo multiplication? I divide. So anything divided by itself is 1. I have p. So 2311 divided by 1.27. Now I don't get a very nice number here. And you'll notice on the answer key, they got this really big fraction. What the heck is that? But if you look at our numbers that we were using, that fraction looks just like it. So because this is going to have to get rounded, we don't like it. We don't want to round answers because it changes the answer. You're shortening the number, you're actually changing the number. So we want to leave this as a fraction. But normally, we don't leave decimals inside of a fraction. And that's what they did to convert their answer. So what they did was they actually multiplied this, and we haven't gone too far into this yet. But they multiplied this by 100, because when you multiply by 100, it moves that decimal 2 places to the right. And as long as you multiply the top and the bottom by the same number, you don't actually change the value of that fraction. So this becomes 2311, and this becomes 127, and that's a nice fraction, no decimals, and it's equivalent. If you divided this and this, so 2311 divided by 127, you'll notice, look, so whether you kept the decimal in it or you made them whole numbers, they're equal. You get the same value. So this is a better fraction. Now, do you need to do any of that on the test? No. So don't freak out about that. But it's good to see, and maybe in the future you'll use that skill. So minus 0.01. Still left with 0.02y. So 0.005 minus 0.01. And we're going to get negative 0.005. Divide that by 0.02. And we get y equals negative 0.25. Let the calculator handle the decimals. Don't let them scare you. All right, we got some simplifying here, parentheses, but I can drop the parentheses by technically distributing the positive 1, which doesn't change anything. The 2 and the minus 9 combine, so it's 3w minus 7. Positive 2 minus 9 is negative 7, so I write minus 7. And now I can add 7 to get rid of it. And I'm going to divide by 3. Now when you do 22 divided by 3, not a nice decimal, so we're not going to round it. We're going to leave our answer. It's 22 over 3. That is a simplified fraction, so it's perfectly acceptable. All right, number 10. We've got some simplifying to do on the left side here. I have two terms with a's in it, so I'm going to combine those terms. It's a 6 and a minus 2. That's a 4a. The minus 3 cannot combine. It does not have the same variable. Add 3 to get rid of it. So 4a equals 20. Divide by 4. And a equals 5. And again, you could run checks on all of these if you wanted to, which I highly recommend on a quiz or a test, but you did not have to on this assignment. Okay, number 12, we're going to write an equation to describe the situation, and then we're going to solve the equation. So number 12, Mark makes an average of 24 typing mistakes per page, but he is improving. Each day he makes 3 fewer. So if he was making 24, 3 fewer would be 21. So think about that. When you go to write your equation, we're not adding 3, we're subtracting 3 because he's making 3 fewer. His goal is to make no more than 3 mistakes per page. How many days will it take Mark to reach his goal? So let's write the expression first. You're starting with 24 and you're minusing 3 per day. So you plug in the number of days that it's been. Every day is 3 less than 24, and depending on the number of days, you know how many mistakes he's making. Now, we want to know when it's no more than 3. So when does this equal 3? So that's where the other side of the equation comes from. What are you actually trying to solve for? So now we want to solve this. I'm going to bring it down here to the bottom. Let's go ahead and actually solve it. So d is on the left side. If I'm going to solve this, I have to get rid of this 24. 24 plus 24 gets a bigger number, so I have to minus it. This minus goes with 3. So this is going to go away. So negative 3d equals negative 21. Now I got to get rid of this coefficient, so I'm dividing by negative 3. Anything divided by itself is 1. So I have a 1d. And a negative divided by negative is positive, and 21 divided by 3 is 7. So the answer here is 7. So after 7 days, he will be making no more than 3 mistakes. He should be making exactly 3 mistakes on day 7. All right, and last page, I'll try and squeeze this work in. We may have to bring it down to the bottom here. So we're going to solve and check. Again, you don't have to do the checks here. We may run a couple just to make sure you can do it. So first thing you should always do, look at your dividing line, and if there's anything you can simplify on the left or the right, do it. Remember, you cannot combine things across the equal sign though. So on the left side, I have an x and an x, so put them together. 7 minus 3, that's a 4x, equals 36. Divide by 4, so x equals 9. These 4's go away and x equals 9. Now we're not going to do a check on all of them, but let's do a check right here. So it's 7 times x, which is 9, plus negative 3 times x, which is 9, equals 36. Then when you do a check, you leave this side alone. You're just running this side to see if you get a 36. So 7 times 9, that's 63, plus negative 27. Now don't automatically assume that that's 36. Plug it in your calculator. Too many students just assume their answer is right, and then there's no point in doing a check at that point if you're not going to actually run the numbers. So you get 36 equals 36, and I know my answer of x equals 9 is correct. Okay, number 2, we're going to distribute on the left side of the equal sign, so 2t plus 10 equals 20. Okay, standard form now, so minus 10. Left with the 2t equals 10, divide by 2, and t equals 5. Okay, number 3, you have to distribute this negative. So the 15w is going to stay. This becomes a negative 4 or minus 4, and this becomes a negative 4w. You have to distribute that like a negative 1. So 29 equals all of this. I still have some simplifying to do. I've got a w and a w on the same side of the equal sign, so combine them. 15 minus 4, that's 11w. Okay, and I need to add 4 to both sides. So that's going to be 33 equals 11w, divide by 11, and final answer w equals 3. All right, looking at the left side of my equal sign here, I've got like terms. I've got a plus 2, and this is a plus 1, so that's 3r, it's a 1 plus 2, and I still have a minus 3. We're in standard form, so let's run it, plus 3 to both sides. I'm left with 3r equals 27, divide by 3, and r equals 9. All right, we only got 2 left here. Number 7, we're going to distribute. Now when we do, this is a negative 2. Okay, so this times y is negative 2y, and a negative times a positive, is a negative. 2 times 41 is 82. Now, you've got 3 terms on this side. 2 of them can go together. That's a positive 20 and a negative 82. So that becomes a negative 62. And I still have negative 2y equals negative 38. So I'm in standard form now. I'm going to work straight down here. I'm going to add 62 to get rid of it because it's negative. So it goes away. I'm going to keep coming down. Negative 2y equals. So I have negative 38 plus 62. So that's 24, dividing by negative 2, and y equals negative 12. Last one. A lot to do on this side. So the 50 is not going to change for a while. Let's go ahead and distribute. That's negative 15x. It's negative 40. The negative also gets distributed. That's negative 7x, and a negative times a negative is a positive 24. 50 is still here, but I'm still not even worried about it. I've got 4 terms here, and some of them are like terms. I need to put them together. So this is a negative 22x. Put these together. Negative 40 plus 24 is negative 16, and now I've got 2 terms. They are not like terms. I'm ready to actually solve this equation. So let's add 16 to both sides. That eliminates here. So I get 66 equals negative 22x. Dividing by negative 22 to clear that out. And that goes in evenly a nice 3 times, and a positive divided by a negative is a negative. Final answer, negative 3.